We've got a last presentation for today, and it's going to be CRUDing Kubernetes cluster with cluster API, presented by Jiri Kremser. So, enjoy.
Okay, thank you. Thank you for the intro. Thank you for having me here. My name is Jirka Kremser, and today I'm going to talk about CRUDing Kubernetes cluster using cluster API. I can't see my slides there. Should I press something? Okay, cool. So yeah, CRUDing for all the devs in the room is like creating, reading, updating, deleting, right? So this is my bio. I worked for Red Hat for 7.5 years. Then I was in Oracle, APSA Group, and now I work for a startup called Giant Swarm, which is a German startup, and we do managed Kubernetes clusters. And we use CAPI heavily. CAPI is shortcut for cluster API. Before I start, I have a question. How many of you were in the talk like 2 hours ago from Alex? Please raise your hand. Cool, a couple of you, yeah, thank you. So I also like 3D printing. These are some of my prints. The top right segment, it's a Grafana dashboard for my 3D printer. It can show you the temperature. And yeah, also like road tripping with my family. These are some of my road trips that I've done. I've got two little kids. And the next one is Japan in a month. So this is a little bit of motivation for cluster API. It comes with a CLI tool called clusterctl, and the basic idea is to have a way to create custom resources for a cluster. So cluster is a normal custom resource in your Kubernetes that can create an external cluster. Like you have a management cluster and workload cluster distinctions. So the first picture shows how to generate those CRs. And if you apply them, you can use clusterctl describe. And if everything goes well, you will have a new cluster ready to your own use. So yeah, as I mentioned, there is a management cluster into which you are talking with kubectl, and you are creating those custom resources. For instance, cluster, infra cluster. I will show them all of them later. And then it will talk to your cloud provider, to your infrastructure, and it asks for creating a VMs, and then it will create those Kubernetes nodes, control planes, and bootstrap everything. I'm oversimplifying that, but this is the main idea, to have a parent-child hierarchy between clusters. So we can have like one management cluster and multiple workload clusters. It doesn't necessarily stop here. You can go deeper, and you can say that one of your workload cluster has a role of management cluster for other workload cluster. So you can basically create arbitrarily deep hierarchies. Why would anybody do it, right? It's fun, but it also can like copy your infrastructure in your company that you can have. There's that convey law, right? Is it called that? You have some infrastructure, some teams in your company. It will often map itself into code or some infrastructure, so this can be helpful. And also, you can do a clusterctl move, which is another subcommand of this CLI tool, and you can basically play with those relationships, and you can have a self-managed cluster. So first, you need some bootstrap cluster that will create your workload cluster, but then you can use clusterctl move to move those CRs that were responsible for creating this workload cluster to the cluster itself. Why is it useful? It may be useful for having a way to update your clusters in the future, because this self-managed cluster will have a way to talk to the infra provider and say, hey, I want a new VMs. And it can, for instance, you can change Kubernetes version to a new one. So it will ask for a new VMs, create a control plane nodes with the new versions, and sunset the old ones. Another nice idea is, or nice benefit is that it supports multiple providers. So these clusters don't have to run in the same environment. You can have the parent, the root cluster running on your localhost, on your laptop, in Kind or K3s or whatever you have. And then you can create clusters in the AWS infrastructure, but also in vSphere, Azure, GCP is there, Rancher. There are like 20 of providers. I've been thinking about how to define cluster API, and I've come with definition that, well, using my words, it's a standardization effort that tries to make the cluster creation similar to all infra providers, but it also provides these two operations. Yeah, this is my interaction with ChatGPT. So let's break it down to smaller pieces, because it's still general. I haven't touched the core components, so let's do that. There is a core cluster API, and so there are 4 components, and each of those comes with own controllers and own CRs. It's kind of complicated concept, but if you get familiar with one set of infra provider, you will be able to work with different infra providers as well. So core is something that's there to be able to support those tools like clusterctl, because it encapsulates the commonalities between all those cloud providers into those CRs. So we've got cluster, machine deployment, machine health checks, machine pool, which is alternative to machine deployment, and others. And there is also controller that reconciles these CRs, custom resources. This one is most probably the most important one. This is the thing that talks to your cloud provider and does the talk. Like if you are using AWS, it will talk to your management console and will ask for machines, right? And will create networking, VPCs, and whatnot. And there is a consensus or a pattern that you will have. I've got used foo as a variable, but it can be AWS, Azure, GCP, vSphere, and the pattern here is that it will prefix all those CRs with this infra. So we will have a cluster, which is a general custom resource, but we will also have a specific one for our infrastructure, which can be AWS cluster, vSphere cluster, GCP cluster. And the idea is to move those bits that are different from provider to provider into those specific CRs. There's also Bootstrap provider, which is useful for, it's necessary part of the whole infrastructure, in the whole ecosystem of CAPI, and it's responsible for turning your machines into Kubernetes nodes. And it does that by using either Cloud Init or Ignition script. So again, it has 2 custom resources. One is template, one is config. Similar concept as in pods. You've got pods template under the deployment spec from which the pods are created, similar in here. So in the template, you will specify basically how the configuration for your kubeadm should look like. I will show it later in the demo. There's similar stuff for control planes, but these are, or control plane is just another Kubernetes node plus something, right? This is API server. So it contains all the configs that had the previous, kubeconfig template, but also things that can enable feature gates in Kubernetes, some new experimental features. Was there certificate alternative names and things like that. And important thing to say here is that all these components are interchangeable. So you can use Bootstrap. Most of the time you will use kubeadm Bootstrap that works with kubeadm, but you can also use different Bootstrap controller if you are run, for instance, on MicroK8's platform. This is the whole picture. So it's a set of custom resources that are somewhat wired together. This cluster is a top-level custom resource that has references to all of them. So it's like umbrella object where you can find all the others. So after you apply this set of CRs, and there are helpers to achieve that, because it's like each infra provider has a template directory where you can start from. There will be some kind of reconciliation from those 3 controllers. And first thing what it does, it adds own back references to the cluster, and they will appear in this .metadata owner references. If you are familiar with Kubernetes internals, this is there to enforce the order of deletion. Like if I then delete all these resources again, there is a rule in Kubernetes that the parent can be removed until the children are removed. So it will basically enforce the order of deletion. Right, and also it will create those machine sets. So here I can see that there was a machine deployment, and similarly in Kubernetes we have deployment, and it will create replica sets. So it's following the similar analogy here, and these machine deployments will create machine sets. And machine set is something that's responsible for creating number of replicas of these machines. So, and machine as again reference to kubeadm config and infra machine. This kubeadm config was taken from this kubeadm config template. So they are like these templates are kind of cookie cutters for those like real instances of those things. Nice thing about it is if you get familiar with this quite complex architecture, and I've like colored the nodes to help you realize which parts are coming from which component, because before we were talking about core components, infra components, bootstrap components, and control plane components. So here, for instance, the green ones are the infra components, and it's used for vSphere, provision for vSphere cluster. And as you can see, it has the prefix all the time in the name of those CRs. But nice thing about it is that if you get familiar with this and you switch to different provider, it's relatively stable. Like the structure is almost similar or is almost identical. The only thing that changes there is the name of those infra resources. So in case of AWS cluster, we will have AWS cluster and not vSphere cluster. But there might be differences, again, in the providers itself. So for instance, AWS provider provides two ways of deploying those Kubernetes clusters. One is called machine deployment, is this one, but it can also use machine pools, which is basically used for managed Kubernetes on the AWS. Right, so, but it's hard to learn about the things without doing them, so I'll prepare the demo, so let's make a quick demo. So I've got my management cluster running, and I have deployed this for controllers. This is the infra controller for CAPI, which is vSphere. These three are coming from the CAPI project itself, the core part, kubeadm bootstrap controller, and controller for control planes. Right, so let me first create and here I will be watching for machines. Machine is CR coming from this cluster API, and we will be able to see the new machines being created. So I'm just running watch periodically. There should be some machines already, and this is actually the workload, the management cluster I'm currently connecting into. So it's self-managed. That's why we see those machines here, because the cluster has the awareness of itself in terms of cluster API. It knows that it has number of replicas for workers and number of replicas for control planes. I can verify that if I list all the nodes. We can see there are 4 nodes, and these are the same as we see in here. Here I'm running GoVC, which is a CLI tool that's able to talk to vSphere API, and it will list as the VMs that appears in vSphere console. Yeah, same stuff here. I also have vSphere console in here in my browser, and this should be also appear in here. Yeah, so only the management cluster is there right now. So let's create a new cluster using cluster API. I will use Helm for that. And I'm templating a Helm chart, and I will show you what's going to be created. It's going to be quite overwhelming. There's a lot of stuff happening. But the most important stuff, this is the cluster. That's the top level object I was showing before. It has references to control plane object, which is also part of this list of things being created, and infrastructure reference to infra cluster. So for instance, this guy will be created in this list of YAMLs as well. So let's find him. Yeah, so this is kubekdm control plane, and as you can see, there are some parameters that can be passed to for API servers. And for instance, we can create new volumes, we can mount files there. For instance, if you want SSH keys to be present on those machines, it's the right place to do it. You know, right at your public keys there. feature flags can be added here for API server. You can change images of core DNS container as well as containers for API servers. And we will be using kubevip, so it contains also configuration for this tool. It's there because if you deploy multiple control planes, we need some HA between them. They will be available under one IP. All right, so let me try to apply it. Helm. Yeah, I'm using Helm upgrade with -e, which is install, and using the same value file. So there is a revision 1, so it worked, and we can see this new images provisioning. It starts first with the control plane, and after control plane, VM for control plane is initialized, and the kubeadm init has been run. We will get the token from this file, from this command, and only then the provisioning for workers can start, and these can run kubeadm join with this token. I don't know if you had KCA certification, it was the stuff that was presented there as well. So it uses by default kubeadm. And we can see that there is a new machine for this control plane. It should appear also here. I guess if I refresh. Yeah, this is the control plane machine. It's gonna take a minute or two. What's not yet? The control plane has been provisioned. We can run the clusterctl describe command, which is pretty nice because it will. Let me first run it. It will grab the information from various places and present it to you at one output. So it's saying that we are still waiting for machine deployments for workers, but the control plane has been finished before 20 seconds. And yeah, because the information is spread around those CRs, it's quite hard to figure out what's happening because they are updating, the status is filled and whatnot. That's the price for having 4 different controllers because they need to talk with each other. Like normally, if you have operator in Kubernetes, it's very simple, right? You have like one operator, one CR, and it does something with the CR. But here the situation is much more complex. We have 4 controllers, and they have to communicate and synchronize themselves somehow. So we can see everything got provisioned. Clusterctl command also give us a way to get the kube config. So let's do that. It takes name of the cluster, but I have it as a variable. Okay. Yeah, so we can use this new kube config to talk to the newly created cluster. So let's list the nodes. We can see it's there, but nodes are not ready. It's kind of expectable because it creates the nodes, but the CNI was not installed there. And together with the clusters, CRs for clusters, we are also creating a Helm release. I haven't shown that, but I'm using Flux here, or Flux controller, and this CNI will be installed eventually, but it may take up to 3 minutes to do that. So I can get back to demo after a while, and this should be ready. So yeah, what's there and what's missing, right? So Cluster API provides a way to do cluster updates easily, or there's a way to do that. It's not that easy because all those CRs are kind of immutable. And if you want to create a new version, say for Kubernetes, you first have to create a new template for this that has this new information, and then rewire those relationships as we were showing before from this cluster to this new template. It's useful because it's one single pane of glass for where you can find your own other clusters. So we can have a kubectl-based API and you can ask like kubectl get clusters, and you will see all of them at one place. It supports scaling well, it doesn't support scaling out of the box, but there is a cluster autoscaler project which is adjacent to cluster API, and you can use it to scale your nodes. There's CLI, and nice thing is that everything is a code, and you can version it in a Git. But it was missing. There is a lot of stuff that's missing, and I will take them one by one. The first one is CNI. That's why the nodes were not ready. So we need to install it by on our own. There are tools like Cilium, Calico, Flannel, Wave, and I'm installing Cilium there. The important thing is that those tools need to tolerate those not ready taint on these nodes, because we need to get the pod running, right? The other part was missing is the CSI, which is a thing responsible for mounting your volumes, right? So if you create persistent volume claim object and you have no CSI present in your cluster, nothing is going to happen. So we need to deploy also infra cloud provider specific CSI that's able to create those volumes on those infrastructures. It's basically all, or CPI, CSI, and CNI almost always run as a daemon set, so each node has this capability there. It can provide a topology feature, like if you have CPI and it tags your nodes with topology information like availability zones, it can utilize this information. You can have some data locality, so you can have your algorithms close to the data. CPI part is kind of fuzzy because, for instance, the CPI for vSphere, it's a cloud provider interface, doesn't come with the native load balancer for services. It's kind of optional to implement it, so it's not there. So here I'll be using kubeweb for instead their implementation. What's also missing is a way to deliver something to your newly created cluster. There is a CR coming from cluster API called cluster resource set, but it's still, I think, experimental feature, and probably it's gonna be removed because there is another project called cluster API add-on provider Helm, and it's basically a way how to deliver content to your workload cluster. So you have a way to create a cluster, but then you have no way to add these CNIs, and things like that there. What I was using is the Helm release, and together with Flux, because Helm release provide a way, it's another CR, custom resource, and there you can provide a kube config, so it can deploy this Helm to a target cluster. So you can have a management cluster when you create this Helm release object, and it will deploy some stuff to your workload clusters. If you have GitOps in place, it's sometimes hard to manage those secrets, but you can use tools like SOAPs or Vault CSI. Yeah. Or you can also use, because it forms a nice tree hierarchy. We have this parent as a management cluster and those workload clusters as children. And this kube config is present in this management cluster. So you can create your own operator running in management cluster that's doing something to your workload clusters. That's a nice design pattern, I would say. Yeah, so load balancing is pretty specific to your cloud provider. So for instance, on AWS, you will have something in there and you can reuse it. But in our case, I'm using vSphere, which is like bare metal VMs. Oh, sorry, just VMs, but nothing there. I think VMware also provides some paid, it's called ALB thing, but if you don't want to pay it, you have to bring your own solution and deploy it and basically have a way to expose your workloads to external world. You can use ingress control, you can use gateway API for that, but you can also use like lower level primitives like services with type load balancer. For instance, Cilium itself comes with MetalLB, and it also can be used for doing it. And there are multiple projects in this cloud-native ecosystem, right? And there are overlaps between them. There was a talk today about Cilium, and Cilium, for instance, can do gateway API, it can do ingress control, and it can also do the service type load balancing for services. So there are overlaps between those tools. Oh, before I go to that slide, let me check if the nodes are ready. Yeah, they are ready. And yeah, so how to start? It's quite complex topic, but there is a tool or infra provider called CAPI, which is Cluster API Docker provider, and then you can try it on your own laptop. You can use the clusterctl init command. It has a subcommand or switch with -- infrastructure where you specify which flavor of CAPI you are using it, and if you say it will be Docker, it's not going to provide any new clusters on some real infrastructure, but it will run new Docker containers on your laptop, and you can play with the CRs, right? You can see how everything is interconnected, and it's not the real use case because the machines will not be like the real machines, but yeah, it's an easy way to start. In Valencia, there was a really nice talk about how to write your own API provider. I really recommend this one because it was also presenting a couple of design patterns that can be used in these providers. For instance, they almost always follow the same structure. They've got like reconcile normal, reconcile delete part methods, or it's like if you know one provider, it's much easier to get familiar with the other ones. How to troubleshoot, right? If things go not so well, it's hard to find an issue because, yeah, as I said, there are 4 different controllers doing the different stuff. So it's like event-based system, right? You have to check 4 different logs, and also a lot of information is spread across those status sub-resources in various CRs. So you have this clusterctl describe cluster tool, describe cluster command that can present you somewhat important things to you, and you can make sense of it and do the right thing about it. Right. And sometimes if you delete the cluster, it heavily uses finalizers. So for instance, if you go and delete one part of the cluster, it will block the execution of kubectl, and it will wait for something that will remove the finalizer. It's there because we need to clean those resources in those real infrastructures, right? If we are deleting a cluster, it first needs to delete those machines, and only then it will allow deletion of this Kubernetes API object. Let me actually try that because I've got 3 minutes, right? Yeah. So if I remove the cluster, it was Helm, so I need to uninstall. Yeah, uninstall these Helm release. Yeah, it's removing the VMs, but as you can see, it's hanging, right? I'm still waiting for kubectl command to finish, and only now it finished. It waited for actual deleting of these VMs, and only then it was able to finish itself. I still have some time, so I can show you also how it can work with GitOps. Because as I said, my management cluster is self-managed, but it's self-managed in a way that these definitions are stored somewhere in a Git. So let me change number of replicas of this management cluster in Git. But it takes some time, so hopefully it will finish before the presentation. I forgot the... Yeah. So is this repo? And the file is called cluster, yeah, this one. So if I search for replicas, this is control planes, but I need workers, which is here. If I change it to 4, edit, committed. Yeah, we also have a pre-commit check that I'm not exposing any secrets. So I still have 3 pods right now, I think. But after some while, I should be able to see the 4th one. But it can take 2 minutes, so I'll switch back to presentation again. Some takeaways. Standards are good, right? It's a common ground for various cloud providers, and we can use it in a similar way. And that's a nice thing to have, right? Because if each provider provides their own API to do the stuff, it wouldn't be that easy to take your existing infra or developer platform and say migrate to some other. So it mitigates vendor lock-in a lot. But it also introduces a lot of complexity because there are 4 different controllers running and communicating with each other through some CRs. It makes a lot of sense with GitOps because if we have infrastructure as a code, it's much easier to version everything, to basically track the changes to our clusters, right? And in Giant Swarm, we can reduce the pain because we support cluster API for different providers. We support CAPI, vSphere, GCP, AWS, Azure, and I think, yeah, that's it. And we are looking into Tinkerbell as well. So yeah, that's all. Thank you.
Well, cool. Thank you very much for the presentation. We've got one question or Slido. It's like if you can.
Right. Yeah. Recommended provider for bare metal, right?
Yeah.
I would recommend Tinkerbell. I have no experience with it, but I think it's like the one to go with. Let me actually, I forgot to check if there is a new, there is new node running here for 31 seconds, so just on time. Any other questions in the audience? Or?
Nope. Still shy till the end of the day. Okay. So we can close it. Okay. Thank you very much for the presentation. And have a nice evening.